Okay, so in the C4 exam, right, you will have a question, okay, perhaps more than one, where you have to integrate sine squared x, right, or cos squared x. And in order to do that, right, you can't, there's no way of just integrating it straight away. You've got to use your understanding of double angles, right? Because if you look at the results up here, right, it's the cos 2a I'm interested in particular. If you notice, a sine squared appears and a cos squared appears. So what we're going to do, we're going to rearrange this in order to integrate something instead of sine squared x. So if we, for instance now, because we're interested in sine squared x, if we look at that middle result there, okay, so if I write down cos 2a equals to 1 minus 2 sine squared a, okay, keep it in terms of a, because that's how you're going to remember the results, or how you're going to work them out in the exam, from page 4, in the identity, trig identities. But that's the result, isn't it, for cos 2a. Now what I'm going to do is, I'm going to take that minus 2 sine squared a, I'm just going to take that over this side, so it becomes a plus 2 sine squared a, and I'll take the cos 2a over that way, so I'll swap them. So if I take the minus 2 sine squared over, it becomes plus 2 sine squared a, 1, and then if I take that cos 2a over, it becomes minus cos 2a. And if we think about it then, if I take that 2 over, okay, if I take that 2 over, I've got a result for sine squared a. And now if I take the 2 over, because we're timesing by 2 here, when I take it over, I'll be dividing the whole thing by 2. Okay? And you get that. You get a result for sine squared a. Okay? You get an equivalent of it. Alright? Now, perhaps a better way of writing that, instead of writing like it all over 2, we could write it as a half. Okay? And then bracket 1 minus cos 2a. We could write it like that, right? So instead of dividing by 2, you can say times it by half. Dividing something by 2 is the same as timesing something by a half, and that's perhaps a better way of writing it. But what you'll notice is sine squared a is equal to this. So when you ask the integral of sine squared x, instead of having to integrate sine squared x, we can just substitute it with this. We can just replace it with what we've got here, okay, with this. So we'll say integral of 1/2 bracket 1 minus cos, okay, and of course now I'll write it in terms of x, like that, yeah? So instead of having to integrate this, we'll just integrate this. Now what I'll do is, I'll take the half out, because it's a constant of integration, and I'm just left inside then with having to integrate this. And it's really simple, it brings, you see, 3 revision, okay? So this becomes then 1/2, as I said, outside. So then we need a bracket. 1 then, when you integrate it, just becomes x. 1 becomes x. And cos 2x, when you integrate it, of course, just becomes sine 2x over 2. Okay? So remember, you just integrate this, sine 2x, and you divide by the derivative, and now it's just 2. And of course, there's a minus in front, because there's a minus here. And don't forget then your plus c at the end, because there's no limits involved in this case. And there's your answer, okay? You've got 1/2 then times that bracket, okay? So we can write that down here. So we're going to have 1/2 x minus sine 2x upon 2 plus c.